In the vast expanse of our solar system, there lies a world that has captivated humanity for millennia, a celestial body bathed in the warm reddish glow of the distant sun, a planet of stark beauty, its silence both alluring and deeply unsettling. This is Mars, the red planet. Our own planet, Earth, teems with life, its surface a vibrant tapestry of oceans, continents, and swirling clouds. Yet even amidst this abundance, we find ourselves drawn to the heavens, seeking answers to questions that have haunted us since the dawn of consciousness. Where did we come from? Are we alone in the universe? These existential inquiries have fueled our desire to explore, to push beyond the familiar and venture into the unknown. And so we set our sights on Mars, a world both familiar and alien, a testament to the power of both creation and destruction. It beckoned us with the promise of discovery, a chance to unravel the mysteries of our solar system and perhaps even glimpse the origins of life itself. The journey to Mars is not merely a physical one, but a journey of the human spirit, a testament to our unquenchable thirst for knowledge and our enduring need to explore the frontiers of our universe. Mars, as we know it today, is a world of stark contrasts. Its rusty red surface, a canvas of ancient impact craters, towering volcanoes, and vast plains of wind-swept dust, speaks of a turbulent past. The planet's thin atmosphere, unable to shield it from the harsh radiation of space, whispers tales of a lost paradise. But beneath this desolate facade lie tantalizing clues hinting at a very different Mars, a planet that may have once been strikingly similar to our own. Billions of years ago, scientists believe, Mars was a much warmer and wetter world. Rivers flowed across its surface, carving out valleys and canyons that still scar its face today. Vast lakes and perhaps even oceans shimmered beneath a thicker, more protective atmosphere. Evidence of this watery past is etched into the very fabric of the planet, from the mineral deposits left behind by ancient seas to the smooth, rounded pebbles that speak of long-gone riverbeds. This tantalizing glimpse into Mars's history raises more questions than it answers. What happened to all that water? Where did the atmosphere go? And perhaps most intriguingly, did life ever arise on this once habitable world? Across cultures and throughout history, the stars have served as both a source of wonder and a practical guide for humanity. Ancient civilizations looked upon the celestial tapestry, weaving intricate myths and legends around the movements of the celestial bodies. Among these celestial wanderers, Mars held a particularly prominent place, its fiery hue and unpredictable movements sparking both awe and apprehension. Unlike the fixed stars, which appear to maintain their positions relative to one another, Mars traced a peculiar path across the heavens. It would appear to move forward for a time, then inexplicably reverse course and move backward in what became known as retrograde motion. This seemingly erratic behavior puzzled early astronomers and fueled speculation about the planet's true nature. The ancient Romans, known for their martial prowess, associated Mars with their god of war. Its blood-red hue, reminiscent of battlefields and spilled blood, seemed to reinforce this association. The Dance of the Planets, a celestial ballet choreographed by gravity, has captivated observers for millennia. From our vantage point on Earth, we witness this cosmic performance as the planets trace intricate paths across the backdrop of stars. Mars, in particular, puts on a captivating show. Its apparent movements are testament to the elegant laws of celestial mechanics. As Earth and Mars orbit the Sun, their relative speeds and positions constantly change. Earth, being closer to the Sun, completes its orbit faster than Mars, overtaking the red planet at regular intervals. It is during these periods of orbital catch-up that Mars appears to reverse its course, moving westward against the backdrop of stars before resuming its eastward journey. This illusion, known as retrograde motion, is a consequence of our perspective from a moving platform. In the vastness of space where darkness reigns supreme and distances are measured in light years, Mars stands as a beacon, a rusty red testament to the enduring allure of the unknown. It is a world both familiar and alien, a celestial mirror reflecting our own planet's past and perhaps offering a glimpse into our collective future. For centuries, Mars has captured our imaginations, fueling our dreams of exploration and igniting our curiosity about the possibility of life beyond Earth. Its crimson glow, piercing the darkness of the cosmos, has served as a constant reminder that we are not alone in this vast universe. It is a celestial invitation to push the boundaries of human ingenuity, to venture beyond the familiar comforts of our home planet and explore the uncharted territories of our solar system. Today, as we stand on the cusp of a new era of space exploration, Mars beckons us with renewed urgency. We send robotic emissaries to pave the way, their instruments probing the planet's secrets and beaming back data that deepens our understanding of this enigmatic world. We develop new technologies, refine our plans, and nurture the dreams of one day setting foot on its dusty surface. Mars is more than just a celestial destination. It is a symbol of our collective potential. It represents the audacity of human ambition, our unwavering determination to overcome seemingly insurmountable challenges, and our innate desire to unravel the mysteries of the universe. It is a dream woven into the fabric of our collective consciousness, a dream that, with each passing day, inches closer to reality. Imagine stepping out onto the surface of Mars. The first thing that strikes you is the silence, a profound, all-encompassing silence, broken only by the gentle whisper of the Martian wind as it dances across the desolate landscape. The air is thin, the sky a pale, dusty pink, and the ground beneath your feet a rusty red, as if sculpted from iron oxide itself. This is a world of stark beauty, painted in hues of ochre, crimson, and burnt orange, a testament to the raw power of nature and the passage of eons. Mars is a planet of extremes. Its surface, scarred by countless impact craters, ancient lava flows, and colossal dust storms, speaks of a tumultuous past. Towering volcanoes pierce the thin atmosphere, their summits dwarfing even the highest peaks on Earth. Vast canyons, stretching for thousands of miles, carve deep furrows across the planet's face, hinting at a time when water may have flowed freely across its surface. This is a world both breathtaking and unforgiving, a place where beauty and danger coexist in a delicate balance. Dominating the Tharsis region of Mars, a vast volcanic plateau, lies Olympus Mons, a testament to the raw power that once surged beneath the planet's surface. This colossal volcano, the largest in our solar system, stands as a silent sentinel, its summit piercing the thin Martian atmosphere and reaching for the stars. Imagine standing at its base, gazing up at its sheer immensity, a shield volcano so vast it could encompass the entire state of Arizona. Olympus Mons is a shield volcano formed by the slow accumulation of lava flows over millions of years. Unlike the steep-sided stratovolcanoes found on Earth, such as Mount Fuji or Mount Vesuvius, shield volcanoes are characterized by their broad, gently sloping profiles resembling a warrior's shield laid flat upon the ground. This distinctive shape is a result of the low viscosity of the lava that erupted from Olympus Mons, allowing it to flow for great distances before solidifying. The caldera, or summit crater, of Olympus Mons is a sight to behold. Spanning some 50 miles in diameter, it dwarfs any volcanic feature on Earth. Imagine peering into this vast depression, its floor a mosaic of solidified lava flows and collapsed lava tubes, a testament to the volcano's fiery past. The sheer scale of Olympus Mons is a humbling reminder of the immense forces that have shaped our solar system. If Olympus Mons represents the verticality of Mars's dramatic landscape, Valles Marineris embodies its horizontal grandeur. Stretching over 2,500 miles across the Martian surface, this colossal canyon system dwarfs Earth's Grand Canyon in both length and depth, a testament to the immense tectonic forces that once ripped through the red planet's crust. Imagine standing on the edge of Valle Marineris, gazing out over a chasm so vast it seems to stretch to the very curvature of the planet. The canyon walls plunge downwards for miles, revealing layer upon layer of ancient rock formations, a geological chronicle of Mars's turbulent past. At the bottom of this chasm, a labyrinth of smaller canyons, mesas, and landslides stretches out before you, a testament to the relentless forces of erosion that continue to shape this alien landscape. Unlike the Grand Canyon, which was carved by the erosive power of the Colorado River, Valles Marineris is thought to have formed through tectonic activity. Billions of years ago, as the Martian crust cooled and contracted, it fractured, creating a series of massive rift valleys. Over time, these valleys were widened and deepened by a combination of volcanic activity, landslides, and wind erosion, eventually forming the awe-inspiring chasm we see today. Valles Marineris is not only a testament to the power of geological forces, but also a window into Mars's ancient past. The exposed rock layers within the canyon walls offer scientists a glimpse into the planet's geological history, revealing clues about its climate, atmosphere, and the potential for past life. By studying the composition of these rocks, researchers hope to piece together the story of how Mars transformed from a potentially habitable world into the dry, dusty planet we see today. Across the desolate plains and towering mountains of Mars, a constant force is at work, shaping and reshaping the landscape with each passing moment: the Martian wind. Though thin and tenuous compared to Earth's atmosphere, the Martian wind plays a significant role in shaping the planet's surface, carving intricate patterns in the sand dunes, polishing rocks smooth, and carrying dust across vast distances. The winds of Mars, driven by temperature differences across the planet's surface, can reach speeds of up to 60 miles per hour, whipping up dust devils that dance across the plains like ethereal beings. These dust devils, some towering miles high, play a crucial role in the Martian dust cycle, lifting dust into the atmosphere and transporting it across vast distances. This constant movement of dust contributes to the planet's reddish hue, as iron-rich minerals in the dust oxidize or rust upon exposure to the Martian atmosphere. The wind's erosive power is evident in the many features etched across the Martian surface. Sand dunes sculpted into graceful curves and ripples by the prevailing winds stretch for miles across the Martian plains. Rocks, exposed to the relentless sandblasting effect of wind-blown dust, are polished smooth, their surfaces etched with intricate patterns. Canyons and craters, their walls eroded by the wind over eons, bear witness to the constant reshaping of the Martian landscape. Today, Mars stands as a testament to aridity, its surface a desolate expanse of rust-colored dust and wind-sculpted rock formations. Yet beneath this parched facade lies a tantalizing mystery, a story whispered by the very rocks themselves, the story of a time when liquid water, the elixir of life as we know it, flowed freely across the Martian surface. Scattered across the red planet like cryptic messages from a bygone era are features that speak of a wetter, potentially more hospitable past. Imagine soaring over the Martian landscape, your gaze drawn to a network of sinuous channels, their meandering paths etched into the ancient terrain. These dried-up riverbeds, some stretching for hundreds of miles, are strikingly similar to those found on Earth, their shapes and structures hinting at the erosive power of flowing water. These ancient waterways, now silent and dry, paint a vivid picture of a time when rivers and streams may have coursed across the Martian surface, carving canyons, depositing sediments, and perhaps even nurturing life in their watery embrace. Further evidence of Mars's watery past can be found in the presence of minerals that form only in the presence of liquid water. Clay minerals, for instance, have been detected in numerous locations on Mars, particularly in ancient crater lakes and river deltas. These minerals, often associated with sedimentary environments on Earth, suggest that water once pooled and flowed on Mars, creating conditions that could have been conducive to life. The evidence for past water on Mars is not limited to surface features and mineral deposits. Data collected by orbiting spacecraft and rovers on the ground have revealed the presence of water ice locked beneath the Martian surface, particularly in the polar regions. These vast reservoirs of frozen water, remnants of a time when Mars's climate was warmer and wetter, hold tantalizing clues to the planet's past and perhaps even its future potential for supporting life. The evidence for a once watery Mars begs a fundamental question. What happened to all that water? The answer, scientists believe, lies in the dramatic transformation of Mars's atmosphere over billions of years. Today, the Martian atmosphere is a mere wisp of its former self, too thin and tenuous to trap enough heat to sustain liquid water on the surface for any significant length of time. But in the distant past, Mars likely possessed a much thicker, warmer atmosphere, one capable of supporting a wetter, potentially more Earth-like environment. So how did Mars lose its atmosphere? The prime suspect in this planetary case of grand larceny is the Sun. Unlike Earth, which possesses a strong magnetic field that acts as a shield, deflecting the solar wind, Mars's magnetic field is weak and patchy. This lack of a global magnetic shield left Mars vulnerable to the relentless onslaught of charged particles streaming from the Sun, known as the solar wind. Over billions of years, the solar wind gradually stripped away Mars's atmosphere, molecule by molecule, thinning it out and leaving the planet exposed to the harsh radiation of space. As the atmosphere thinned, the pressure at the surface decreased, causing any liquid water to evaporate into the atmosphere or freeze beneath the surface. The once thick atmosphere, capable of supporting a warmer, wetter climate, was reduced to a mere whisper, leaving behind a cold, dry world. At the northern and southern extremities of Mars lie gleaming beacons of white, contrasting sharply with the rusty red hues of the surrounding landscape, the Martian polar ice caps. These icy realms, visible even from Earth through telescopes, hold not only the key to understanding Mars's past climate, but also a potential resource for future human exploration. The Martian polar ice caps are composed primarily of water ice, with a layer of carbon dioxide ice, or dry ice, seasonally depositing on top during the Martian winter. The northern polar cap, larger and more easily accessible, is estimated to contain enough water ice to cover the entire planet to a depth of about 35 meters, if melted. These icy reservoirs represent a significant fraction of Mars's total water inventory, frozen in time and offering a glimpse into the planet's past. The layers within the polar ice caps, like the rings of a tree, record the history of Mars's climate over millions of years. By analyzing the composition and thickness of these layers, scientists can glean insights into past variations in Mars's orbit and tilt, which influence the amount of sunlight reaching the poles and thus affect the growth and retreat of the ice caps. These variations in climate, recorded in the frozen archives of the polar caps, may hold clues to the conditions that led to the formation and disappearance of liquid water on the Martian surface. While the Martian surface today is a dry, desolate expanse, scientists believe that vast reserves of water may still exist hidden beneath the planet's surface. These subterranean reservoirs, shielded from the harsh radiation and thin atmosphere that characterize the surface, could hold the key to understanding Mars's past habitability and perhaps even harboring life today. Evidence for subsurface water on Mars comes from a variety of sources. Radar data collected by orbiting spacecraft have revealed the presence of what appear to be large bodies of liquid water trapped beneath the Martian South Polar ice cap. These subsurface lakes, if confirmed, would be a significant discovery, suggesting that geothermal heat from the planet's interior could be melting the ice and creating environments potentially suitable for life. Further evidence for subsurface water comes from the detection of methane in the Martian atmosphere. Methane, a gas often associated with biological activity on Earth, is quickly broken down by sunlight in the Martian atmosphere, suggesting that there must be an active source replenishing it. One possibility is that methane is being released from underground reservoirs, perhaps by microbes thriving in watery environments beneath the surface. The search for subsurface water on Mars is a key focus of current and future missions. The European Space Agency's ExoMars rover, scheduled to land on Mars in the coming years, will be equipped with a drill capable of penetrating several meters beneath the surface, allowing it to search for signs of past or present life in the Martian subsurface. The discovery of life on Mars, even in microbial form, would be one of the most profound discoveries in human history, fundamentally altering our understanding of our place in the universe. The tantalizing evidence of ancient rivers, lakes, and perhaps even oceans on Mars ignites a profound question. If Mars was once a water-rich world, could it have also been a cradle for life? The possibility, however remote, sends shivers of excitement down the spines of scientists and dreamers alike. Could life in some form have emerged on this now desolate world, leaving behind whispers of its existence in the Martian soil? Billions of years ago, when Mars was a younger, warmer planet, its surface conditions may have been remarkably similar to those on early Earth, where life first arose. Liquid water, the essential ingredient for life as we know it, flowed freely, carving channels and pooling in craters. A thicker atmosphere would have provided protection from harmful solar radiation, and volcanic activity could have supplied the planet with heat and essential nutrients. These conditions, while fleeting on a geological timescale, could have provided a window of opportunity for life to emerge. On Earth, life persists in even the most extreme environments, from the depths of the oceans to the scorching vents of volcanoes. These extremophiles, as they are known, demonstrate the remarkable adaptability of life and suggest that it might be able to eke out an existence in environments that we once considered uninhabitable. If life could evolve in the extreme environments on Earth, could it have also found a foothold on a young, watery Mars? As we delve deeper into the Martian mystery, we encounter tantalizing clues that fuel the debate about the possibility of life on the red planet. One such clue comes in the form of methane, a simple organic molecule that has been detected in the Martian atmosphere, albeit in trace amounts. While methane can be produced by geological processes, its presence on Mars has sparked intense speculation about a possible biological origin. On Earth, methane is primarily produced by living organisms, from microscopic bacteria in the guts of cows to vast colonies of methane-producing microbes thriving in oxygen-deprived environments. While geological processes such as volcanic activity or the interaction of water with certain rocks can also release methane, the fluctuating levels detected on Mars, with spikes occurring seasonally, suggest a more dynamic source. The possibility that the Martian methane is biological in origin is a tantalizing one, hinting at the possibility of microbial life still existing beneath the planet's surface. These hypothetical Martian microbes, shielded from the harsh radiation and thin atmosphere of the surface, could be releasing methane as a byproduct of their metabolism, much like their counterparts on Earth. However, the methane mystery is far from solved. The detection of methane on Mars is a complex and challenging endeavor, and the source of the gas remains a subject of ongoing debate. Future missions, equipped with more sensitive instruments and the ability to collect and analyze samples from the Martian subsurface will be crucial in determining whether the whispers of methane are indeed a sign of life or simply the echoes of geological processes. The search for life beyond Earth is, in many ways, a search for ourselves, a quest to understand our place in the grand tapestry of the cosmos. The discovery of even the simplest life forms on Mars, a planet so seemingly different from our own, would have profound implications, forcing us to reconsider our assumptions about the nature of life and the possibility of its existence elsewhere in the universe. The focus of the search for Martian life has shifted in recent years from the surface, where the harsh conditions make survival unlikely for any but the hardiest extremophiles, to the subsurface, where liquid water may still exist and conditions are potentially more hospitable. Underground caves, ancient hydrothermal systems, and the depths of impact craters all hold promise as potential havens for Martian life, past or present. Future missions to Mars will be equipped with increasingly sophisticated tools for detecting signs of life, from instruments that can analyze the chemical composition of Martian rocks and soil for biosignatures, to rovers capable of drilling deep beneath the surface to access pristine samples. These missions will also focus on exploring the Martian subsurface, searching for evidence of liquid water and potential habitats for extant life. The discovery of a second Genesis, a separate origin of life on another world, would be a watershed moment in human history, fundamentally altering our understanding of our place in the universe and opening up a realm of possibilities for the existence of life beyond Earth. It would demonstrate that life is not a fluke, not a one-time event confined to our pale blue dot, but rather a force woven into the very fabric of the cosmos, capable of emerging and evolving in diverse and unexpected ways. The search for life on Mars is a journey of discovery, a quest for knowledge that transcends the boundaries of our planet and propels us toward a deeper understanding of the universe and our place within it. For centuries, humanity could only gaze upon Mars from afar, its fiery glow in the night sky a distant beacon of our celestial aspirations. But in the latter half of the 20th century, fueled by technological advancements and an unyielding spirit of exploration, we began to reach out to our celestial neighbor, dispatching robotic emissaries to pierce the veil of distance and unveil the secrets of the red planet. The first tentative steps in our robotic exploration of Mars began in the 1960s with the Mariner program, a series of flyby missions designed to capture the first close-up images of the Martian surface. These early glimpses of our celestial neighbor, though grainy and limited by the technology of the time, revealed a world both familiar and alien, with craters, canyons, and vast plains of dust. The success of the Mariner missions paved the way for even more ambitious endeavors. In 1971, Mariner 9 became the first spacecraft to orbit Mars, providing a global view of the planet and revealing the full extent of its diverse and awe-inspiring landscape. For the first time, we saw the towering peaks of Olympus Mons, the sprawling canyons of Valles Marineris, and the intricate patterns etched into the Martian surface by wind and dust. As the 20th century drew to a close, our robotic exploration of Mars entered a new phase, one characterized by rovers, mobile laboratories capable of traversing the Martian surface and conducting in situ scientific investigations. In 2004, two such rovers, named Spirit and Opportunity, touched down on opposite sides of the Red Planet, their mission to search for evidence of past water and assess the planet's potential for harboring life. Spirit and Opportunity, twin rovers the size of golf carts, were equipped with a suite of scientific instruments, including cameras, spectrometers, and a rock abrasion tool, allowing them to analyze the composition of Martian rocks and soil in unprecedented detail. Their names, chosen from a student essay contest, perfectly captured the spirit of these intrepid explorers, a spirit of adventure, a thirst for knowledge, and the opportunity to rewrite our understanding of Mars. Over the course of their missions, which far exceeded their initial 90-day life expectancies, Spirit and Opportunity roamed the Martian surface, sending back a treasure trove of data that revolutionized our understanding of the Red Planet. They found evidence of past water activity in the form of mineral deposits, ancient lake beds, and even signs of hydrothermal vents, suggesting that Mars was once a much warmer and wetter world than it is today. The legacy of Spirit and Opportunity extends far beyond their scientific discoveries. These two resilient rovers captured the imaginations of people around the world, sparking a renewed interest in space exploration and inspiring a generation of scientists, engineers, and dreamers. Their journey across the Martian plains, a testament to human ingenuity and perseverance, demonstrated the power of robotic exploration to expand our knowledge and push the boundaries of what's possible. Building upon the legacy of Spirit and Opportunity, NASA sent two even more sophisticated rovers to Mars: Curiosity, which landed in 2012, and Perseverance, which touched down in 2021. These car-sized robotic explorers represent a quantum leap in our ability to explore and understand the Red Planet. Their advanced instruments and capabilities, allowing them to delve deeper into Mars's history and search for signs of past or present life. Curiosity, true to its name, was designed to explore Gale Crater, a vast impact basin thought to have once held a lake. Its primary mission was to determine whether Mars ever offered conditions suitable for life, and its findings have been nothing short of groundbreaking. Curiosity has found evidence of ancient rivers and streams, detected organic molecules preserved in Martian rocks, and even observed seasonal variations in methane levels, hinting at the possibility of ongoing biological activity. Perseverance, the latest in our lineage of robotic explorers, landed in Jezero Crater, a site chosen for its potential to preserve signs of ancient life. Equipped with a drill capable of collecting rock and soil samples, Perseverance's primary mission is to search for biosignatures or chemical fingerprints of past life, and to cache those samples for eventual return to Earth. This sample return mission, a complex undertaking involving multiple spacecraft and international collaboration, represents the next frontier in our exploration of Mars, offering the potential to analyze Martian samples in Earth-based laboratories and answer definitively whether life ever existed on the Red Planet. Curiosity and Perseverance, along with their predecessors, have fundamentally reshaped our understanding of Mars, transforming it from a distant, enigmatic world into a place we are beginning to know. Their discoveries have fueled our curiosity, ignited our imaginations, and strengthened our resolve to continue exploring this alien world, seeking answers to some of the most profound questions facing humanity. While our robotic emissaries have paved the way, revealing the wonders and secrets of Mars, the ultimate goal of Martian exploration remains firmly in sight: to send humans to walk on the Red Planet, to experience its alien beauty firsthand, and to establish a permanent human presence beyond Earth. This next giant leap, a defining moment in human history, represents not only a technological challenge but also a testament to our indomitable spirit, our innate drive to explore, and our enduring fascination with the unknown. The challenges of sending humans to Mars are immense. The journey itself, lasting several months each way, will expose astronauts to prolonged periods of weightlessness, cosmic radiation, and psychological stress. Landing on Mars, with its thin atmosphere and unforgiving terrain, will be a feat of engineering and human skill, and surviving on the Martian surface, with its extreme temperatures, limited resources, and potential hazards, will require ingenuity, adaptability, and a profound sense of purpose. Despite the challenges, the rewards of sending humans to Mars are immeasurable. Astronauts exploring the Martian surface will be able to conduct scientific research with a level of detail and flexibility that no robot can match. They will be able to explore vast areas, collect samples from diverse locations, and react in real time to unexpected discoveries. And perhaps most importantly, they will be able to share their experiences with the world, inspiring future generations and fostering a deeper appreciation for the fragility and interconnectedness of life in the universe. The journey to Mars will be fraught with challenges, but it is a journey we must undertake. It is a journey that will test the limits of our technology, our ingenuity, and our spirit. But it is also a journey that holds the promise of profound discoveries, unparalleled adventures, and a future where humanity becomes a multi-planetary species, expanding our reach into the cosmos and ensuring the survival of our species for generations to come. The allure of Mars, with its rusty red plains and the tantalizing possibility of past life, beckons us to envision a future where humanity establishes a permanent foothold on the red planet. Yet, as we peer beyond the romanticism of interplanetary exploration, we encounter a stark reality. Mars, in its current state, is a harsh and unforgiving world, a hostile embrace that will demand every ounce of our ingenuity and adaptability if we are to survive and thrive on its surface. The Martian atmosphere, a mere wisp compared to Earth's protective blanket, poses one of the most significant challenges to human survival. Composed primarily of carbon dioxide with a surface pressure less than 1% that of Earth, the Martian atmosphere offers little protection from the sun's harmful radiation or the frigid temperatures that plummet to minus 270 degrees Fahrenheit or minus 168 degrees Celsius during the Martian night. Stepping out onto the Martian surface without a pressurized suit would be akin to stepping out into the vacuum of space, with disastrous consequences. The lack of a substantial atmosphere also means that liquid water, essential for life as we know it, is scarce on the Martian surface. While evidence suggests that liquid water flowed freely on Mars billions of years ago, today it exists primarily as ice locked beneath the surface or as vapor in the thin atmosphere. Accessing and utilizing this precious resource will be crucial for any long-term human presence on Mars, requiring innovative technologies and a deep understanding of the planet's hydrological cycle. Beyond the challenges of air and water, Mars presents a host of other hazards to human health and well-being. The Martian soil, rich in perchlorates and other toxic chemicals, poses a threat to both human health and the integrity of equipment. The planet's weak gravity, about 38% that of Earth, could have long-term effects on human physiology, potentially leading to muscle and bone loss, and the psychological challenges of living in a confined, isolated environment millions of miles from home should not be underestimated. Engineering a second home, the challenges of Martian settlement. The dream of establishing a permanent human presence on Mars hinges on our ability to overcome the planet's inherent hostility and transform it into a more habitable environment. This monumental task, a testament to human ingenuity and determination, will require a multifaceted approach, encompassing everything from developing advanced life support systems to terraforming the Martian environment over generations. One of the most pressing challenges will be creating self-sustaining habitats capable of providing breathable air, clean water, and protection from radiation. These habitats, likely constructed using a combination of Martian resources and materials brought from Earth, will need to be airtight, pressurized, and shielded from the harsh Martian environment. Advanced life support systems will be crucial, recycling air and water, filtering out toxins, and regulating temperature and humidity to create a comfortable and safe living space for Martian settlers. Food production on Mars will be another significant hurdle. The Martian soil, while containing some essential nutrients, lacks the organic matter and beneficial microbes found in Earth's soil. Growing crops on Mars will likely require enclosed hydroponic systems, where plants are grown in nutrient-rich solutions rather than soil, or the development of techniques to enrich and amend the Martian soil for agriculture. Energy production on Mars will require harnessing both local and imported resources. Solar panels, while less efficient on Mars due to the planet's distance from the Sun, will likely be a primary source of power, supplemented by nuclear power sources or other advanced energy technologies. Exploring and utilizing Martian resources such as water ice for fuel and construction materials will be essential for creating a self-sustaining settlement. The Martian dream, a testament to human ingenuity. The challenges of living on Mars are daunting, but they are not insurmountable. Throughout history, humanity has demonstrated an uncanny ability to overcome seemingly impossible odds, driven by a thirst for knowledge, a spirit of adventure, and an unwavering belief in our own potential. The Martian dream, once relegated to the realm of science fiction, is now within our grasp, a testament to our ingenuity, our resilience, and our unyielding desire to push the boundaries of what's possible. The journey to Mars will require not only technological advancements, but also a fundamental shift in our perspective. We must embrace the challenges of living in a closed-loop system, where resources are finite and waste must be carefully managed. We must adapt to a new way of life, one that prioritizes sustainability, resourcefulness, and a deep respect for the delicate balance of our artificial ecosystem. The Martian dream is not just about survival, it's about thriving. It's about creating a new branch of human civilization, one that embraces the challenges and opportunities of living on another world. It's about pushing the boundaries of human knowledge, exploring new frontiers, and inspiring future generations to reach for the stars. The journey to Mars will be long and arduous, but it is a journey worth taking. It is a journey that will test our limits, challenge our assumptions, and ultimately redefine what it means to be human. And as we take our first tentative steps on the Martian surface, we will do so not just as explorers, but as pioneers, laying the foundation for a future where humanity becomes a multiplanetary species, our reach extending far beyond the confines of our home planet. The red planet beckons. As we conclude our journey through the valleys, volcanoes, and whispers of ancient Mars, we stand on the precipice of a new era. The red planet, once a distant point of light, a fiery symbol in our night sky, is now a tangible destination, a testament to human ambition and the relentless pursuit of the unknown. No longer just a celestial object for telescopic observation, Mars beckons us with the promise of discovery, the allure of unraveling its mysteries, and the potential to redefine our place in the cosmos. The journey ahead will be fraught with challenges, a tapestry of technological hurdles, existential questions, and the daunting task of transforming a seemingly barren world into a second home for humankind. Yet the spirit of exploration, that inherent human drive to push beyond the horizon, to venture into the uncharted territories of our universe, burns brightly within us. The same spirit that drove our ancestors to cross oceans, to scale mountains, to chart the course of the stars, now compels us to set our sights on the red planet. The challenges of Mars are not insurmountable. The ingenuity and determination that allowed us to conquer the skies, to land on the moon, to build a permanent presence in low Earth orbit, will guide us as we navigate the complexities of interplanetary travel, habitats construction, and resource utilization on a distant world. Each obstacle overcome, each milestone reached, will bring us closer to realizing the dream of humans walking on Martian soil, their footprints a testament to the unwavering spirit of exploration that defines our species. A universe of possibilities. The red planet, once a symbol of war and conquest in the minds of our ancestors, now represents a beacon of hope and opportunity. It is a blank canvas upon which we can paint a new future for humanity, one where we transcend the limitations of our home planet and embrace the challenges and rewards of becoming a multi-planetary species. The journey to Mars is not an escape from Earth's problems, but rather an investment in our collective future, a testament to our belief in the resilience and adaptability of the human spirit. The knowledge and technologies we develop in our pursuit of Mars will have profound implications for life on Earth. The challenges of living sustainably on a resource-constrained world will drive innovation in areas such as renewable energy, closed-loop life support systems, and advanced materials science. Innovations that can be applied to address some of the most pressing issues facing our planet. The journey to Mars is not a solitary endeavor, but rather a collaborative effort that will unite humanity in a common goal. The complexities of interplanetary travel, habitat construction, and resource utilization will require the combined expertise of scientists, engineers, architects, artists, and dreamers from all walks of life, transcending national boundaries and cultural differences in pursuit of a shared vision. The Red Planet beckons, not as a destination, but as a stepping stone, a launch pad to a universe of possibilities. The journey to Mars is a journey into the unknown, a journey that will test our limits, ignite our imaginations, and ultimately lead us to a deeper understanding of ourselves and our place in the cosmos. It is a journey that we embark on not just for ourselves, but for all of humanity, for generations to come, and for the future of life itself. The Red Planet beckons, and we, the explorers, the dreamers, the inheritors of a legacy of discovery, are ready to answer the call.